Hello everyone, I hope you're doing absolutely well. In this video, we are going to get you aware about TCP stealth scan, which is a part of port scanning technique. This is basically useful for reconnaissance part in pen testing lifecycle. So what is the purpose of TCP stealth scan and how to implement it, that we are going to cover in this video. So talking about the purpose of TCP stealth scan, as we have studied in the part 1 about the TCP acknowledgement scan, what TCP acknowledgement scan do is they send a sync packet and they receive a sync plus acknowledgement, and then it send an RST packet to terminate the connection to get we aware about what the ports are open or closed. So basically in TCP stealth scan, what generally the purpose is that it is going to avoid port scanning detection by the firewalls. So the main purpose here is this scanning is done to avoid the port scanning detection by the firewall. Okay, so let's have some graphical representation of what we are going to implement in TCP stealth scan. Suppose we can say that this is the client and this is the server. This is client and this is server. So in the acknowledgement scan, this is basically same as acknowledgement scan. So what here is do is it send the sync packet to the server, and if the server acknowledgement with sync plus acknowledgement, then we can say that the port is open, and to terminate the connection we client have to send RST packet. So what here do is we send sync packet, after that it receive sync plus acknowledgement, and then after that client has to send RST packet to terminate the connection. So what generally sync packet is to do it, there are many packets which is available in TCP header. The purpose of TCP sync packet is to, whenever we want to start a connection, or we can say that whenever we want to start a connection to victim, or we can say that our client or our server, we have to send TCP sync packet to get to know aware about the client or server that we are going to send you packet. If the server is ready to accept the packets, then the server respond with sync plus acknowledgement. So after that the communications between the client and server is been done. So the main packet, the initial packet, is the sync packet. And if so, here we came to know about that the port is open, but if we get RST packet, but instead of this packet, this sync plus acknowledgement packet, we get suppose instead of sync plus acknowledgement, we get RST packet instead of sync plus acknowledgement. So the server is not, we can say that the port is closed, simply the port is closed. If we receive RST packet instead of sync plus acknowledgement, we came to know about that the port is closed. So without wasting so much of time, we are going to implement this in a, yes, of course, Kali Linux. Okay, so we are going to take one text editor. Yes, currently PyCharm is not installed in my Kali Linux, so you can also implement in PyCharm as well. It is a integrated development environment basically designed for Python programming. Here we are doing socket programming for communication of TCP and IP. So for the communication between client and server, we have one package in Python programming that is called SCPy. We have to import it, and Python, the SCPy library is available only in Python version 3. So if you are trying in Python version 2 or any version previous than the 3, then it will not be implemented. So from scapy.all import star, we are going to first save it so that it's look like some colorful. we can say that TCP stealth scan.py. Okay, so we have to, so for sending some packets to the client, or we can say the server, we have to send one packet that consists of some sync packet. We have to initiate the connection. So for initiate the connection, we need to send one packet, and in that packet we have to set one we can say that variable that is called source port. So we are not defined any source port. So ranshot ranshot will automatically generate any number that is not that much important. We are defining one function that is TCP stealth scan, and in that function we are going to pass two arguments, that is IP address, which we want to conduct an assessment that the port is active or not, or we can say that open or not for the TCP stealth scan, and the second argument is port number, on which we have to get the information regarding the same. So we can say that destination port, destination we can say IP, destination port. So you have to be aware of some of the syntax of the Python programming. Okay, so we have to create one packet, still scan response. Okay, SR1, we are going to create one packet, IP destination is equal to argument which is passed. So the code I am writing is creating a packet. So here we have to set one flag that is sync packet, and timeout we can say 10 numlog. Okay, so here what we have done is we have created one packet and then storing that variable that is still scan response. This is the packet in which we have set the flag, set it to a TCP packet for source and destination port, source port, and the flag, and as well as for the timeout. So first if condition, first is condition that we have to check that we can copy that is have response or not, that it is none or not. So if it is none, then we have to print that the port is filtered. Okay, elif, that is else if still scan response dot has layer. This is has layer TCP here we are checking that the has layer is TCP or not. If it is TCP, then we are going to check that if the response dot get layer, it will get the informations about the layer of TCP dot flags is equal to 0 into 12. Don't be confused about 0 and what is a 0 multiplied by 12. It will be covered in the further It will be covered in the further of the video. First we going to send it. Here we are checking that in this if condition we are checking that suppose we are sending the packet from this. We inserted one packet and we have sent it to the victim, or we can say that server. So setted one SYN packet, and in response to that, if we receive acknowledgement, then we first have to send reset to the server, so that it will not wait for any other further communication to be done. So destination is destination IP, TCP source port, setted one source port, destination port we have setted. Flag, in the flag we have to set, what we have to set, we have to set reset, that is R, and as well as timeout for 10 seconds. Okay. So after resetting, we have to print and let to display on the console that port is open, and if another condition we have to check that the response dot get layer TCP dot flags is equal to 0 into 14. Then we have to print that the port is closed. Okay, and we have to check one another condition, that if the response dot hash layer is ICMP, then again we have to check that which suppose we can say that ICMP error has been occurred, so we have to check that which there are some of the types and some of the codes. So here we are checking that generally there is an in type 3 of ICMP error, in type 3 the destination unreachable error is there. So in type there are other such codes. In such code I have analyzed that 1, 2, 3, 9, 10 and 13, and for 1 these are the codes which I have been saying that 1, 2, 3, 9, 10, 30, these are codes of ICMP error type 3. We are checking that for the same. So if we say that integer stairs and response dot get layer ICMP dot type equal to 3, we are checking this type of the layer ICMP error which will be occurred, and init dot get layer ICMP dot code in 1, 2, 3, 9, 10 and 13. So what is these are the codes? So for code 1 it is stated that the host is unreachable, and for the second code it states that the protocol is unreachable, in third it states that the port is unreachable, in 9 it states that the communication between the destination network is administratively prohibited, in 10th code it states that communication between the destination host is administratively prohibited, and in 13th code it states that communication is administratively prohibited. So if this type of ICMP error is occurred, so what we have to print, because there may be possibility that there are many firewalls structured, and that is so much of security firewalls are there or not. So what we have to do is we have to analyze for the same. So print that the port is filtered, and we can came to know that by knowing this we can say that the port is filtered, and we came to know about that it may be detected or maybe not be detected by the firewall. So for running, we have to run the function TCP state scan. I have set it on my lab for Ubuntu. So the IP address is 192.169.30. And which port we have to analyze? So one port. So we came to know that 2280.631 port is open in this particular operating system. So we are going to check for 22. We are going to open terminal and run for the same. Let's stop sudo. You have to run this with sudo privileges. What to say? TCP still scan.py. Okay. There are some error. Okay. Indentation error. Okay. So this is the final program after solving that error which we have faced. So after running this, hope we will not get an error. So they are sending the packets, and it stated that okay. So we came to know that the port is open. So the port is open. Now we are going to check with another port 23. So it stated that the port is slow. What I have done is I have printed for you people that what is the flag which includes. So you're going a proper idea of what we are checking in this 0 into 12. So what we are receiving in this get layer TCP.flags is, if the port is open, we receive SA, that is sync plus acknowledgement, and if the port is closed, then we receive RA, that is reset plus acknowledgement, which we have discussed here. Reset, if it is reset, then the port is closed, and if the sync plus acknowledgement is received, then the port is open. These are the server responses which we are capturing. So guys, thank you so much guys for watching this video. I hope you like this video, and if you guys want to support us, please subscribe our channel.